The new section is entitled Conditional Distributions. And there are two cases, one of which we will do in this video, and the next one, or the second, will be in the next video. Distributions. We are going to be concerned with ourselves for this video with the discrete case. Next section will be the continuous case. Now, recall that for conditional probabilities, that the probability of E given F is the probability of E and F divided by what comes after the given that line. That is, divided by P of F. And this only makes sense if P of F is not 0. Keep in mind there's three types of numbers: negative numbers, 0, and positive numbers. Well, probabilities are never negative, and if you don't want something to be 0, then you want it to be positive. Okay, so P of F needs to be positive for that conditional probability to make sense, or to use this formula. Okay, so now we suppose X and Y are discrete random variables. Suppose X and Y are discrete random variables. What can we say about the probability for P sub X given Y of X plus Y? Well, it's the of course, X given Y. It's going to be the probability that X is little x given that Y is little y. But by definition, it's the probability that X is little x, Y is little y, divided by the probability that Y, big Y, is y. But this is nothing more than P of xy divided by the bottom doesn't talk about x. It's P sub y of y. P sub y of big Y equals little y. And this is going to be for all y such that the bottom is not negative. In this case, that means positive, because it sure won't be negative. It's a probability. Okay. So now, what about capital F, the cumulative distribution? What would F sub, the name of the random variable, of X given Y equal? Well, it's going to be the probability that X is less than little x, given that Y equals Y. We know what means that. But in terms of writing it like this. Now, let's just suppose capital X being discrete. It takes on 0, 1, 2, 3, even forever, or up to 100. But let us concentrate on 4. Little x is 4. So, if we're less than 4, forget the given that part for a moment. If x is less than 4, we want P of 0, plus P of 1, plus P of 2, plus P of 3, plus P of 4. Given that Y is little y. Given that Y is little y. I didn't leave room, but given that Y is little y. Given that Y is little y. Notice that X values are less than or equal to 4. Because that's what X is. And we add it up. So we're going to add up the probabilities P sub X given Y of A is going to be given Y. And what can we say about A? And the answer is, if we use our numerical example, we want A to be less than or equal to 4. We want A to be less than or equal to 4. But in the general case, it's not really 4. That's not a 4, that's little x. We want the A's to be no bigger than little x. That is, whatever values that x can take on, that's less than little x, we want to find P of that value given Y and add them all up. So that makes sense, that is the formula. Now, what if x and y are independent? What if x and y are independent? Suppose we are now given x and y independent. X and y are independent. Well, this up here will just be the probabilities that x equals little x times the probability that y equals little y, divided by just what it says, the probabilities that y equals little y. And this cancels out, and all you're left with is that, the probability that x equals little x. That is, this probability, P sub x given y of little x given little y, is going to just equal the probability that x equals little x if, in fact, x and y are independent. Straightforward proof to show that. Just use the formula and things canceled out. Okay, let's look at this simple example. Suppose that, well, let me start off this way. All right, look here. Suppose that P of xy, which is the joint probability mass function, the joint probability mass function is given by the following. Well, I should say the joint probability mass function of x and y. The joint function of x and y is given by P of 0, 0 is 0.4, P of 0, 1 is 0.2, P of 1, 0 is 0.1, and P of 1, 1 is 0.3. So just to note, remember, it's not always this way, but it's reasonable to assume the first number is x and the second number is y. Unless otherwise told, that's what it is. Why are we going to confuse people and write y and then x? It's not the way the alphabet goes. It's not the way these PDFs go. So in any case, it seems like x's take on the values 0 and 1, and coincidentally, the y values also take on the values 0 and 1. Okay. So let's just note that. The x's and y's did not have to take on the same values. Now suppose you were asked to calculate the conditional probability mass function of x given something, of x given that y is equal to the number 1. So basically, the answer we want, we'll put down here. We want to know what p of x given y of, well, that should be capital Y, of 0, x can be 0, given that y is 1. I want to know what that is. And I also want to know, now x can also be 1. Y is always 1, but x can be 1. I want to know these two answers. What do these two equal? Well, by definition, I can go by that. By definition, it's going to be p of 0 and 1 divided by py of 1. And the bottom one is going to be p of 1, 1 divided by py of 1. Now, in each of these fractions, I know the numerator, p of 0, 1 is 0.2. And the other numerator, p of 1, 1, that's 0.3. What I need to do is find the bottom. What is py of 1? That means y is always 1, and x can be all the values it takes on. That is, x can be 1, y is 1, plus x can also be 1, y is 1. Another way of writing that, in case there were many different values that x can take on, is the summation of p of x1 over all x. X only being 0, oops, that didn't write. The summation of p of x1 over all x's. X being 0 and 1 in this particular case. So it's p of 0, 1 plus p of 1, 1. Well, p of 0, 1, well, it happens to be right in front of us. It's 0.2. Or if you prefer, you can look up here, 0.2. Plus p of 1, 1 is 0.3. When you add these, you get 0.5. So now, other than reducing a little bit, I'm done. Okay, doesn't want to write that low. Over 0.5, over 0.5. Wow, got to put the eraser down better. Over 0.5. So here I get 2/5, and on the bottom here I get 3/5, and the problem's done. I found the conditional probability mass function of x given that y is always 1. How much are p of all the different x values? X can take on 0 and 1, so we find p of x equaling 0, and we find p of x equaling 1. But in both cases, given that y is 1. Given that y is 1. Okay, let's try another problem. Suppose x and y are independent Poisson random variables. Suppose x and y are Poisson random variables with respect to the parameters lambda 1 and lambda 2. We want to calculate the conditional distribution of x given that the sum of the random variables happens to equal the number y. This is exactly what we want to know. That is, what is the probability that x equals something given that the sum of the random variables is n? Well, this is a conditional, so it's the probability that x is little x and, now, if x is little x, bringing that over to the other side, we know that y is n minus x. And I just want to use, I don't want to use little x. I want to use k. So it's k. Little x is k. So we get k and n minus k. Okay. Well, over the probability of this, that x plus y is equal to n. So the numerator is just since it's independent, let her state that, I'm sorry. X and y are independent Poisson random variables. So I can just say this numerator is the probability that x equals k times the probability that y is equal to n minus k divided by this in the bottom. But now, keep in mind that this in the bottom we've already done. This in the bottom is e to the negative, see if I remember, lambda 1 plus lambda 2 times lambda 1 plus lambda 2 are to the nth power all over n factorial. Okay, so now let me write this underneath. So now this probability, since it's Poisson, this is going to be e to the negative lambda 1 times lambda 1 to the k over k factorial times this probability, which is going to be e to the negative lambda sub 2, lambda sub 2 to the n minus k, that should be factorial, over n minus k factorial, divided by this, which equals this. But instead of dividing by that or dividing by this, I'll multiply by the reciprocal. N factorial over e to the negative lambda 1 plus lambda 2 times lambda 1 plus lambda 2 to the n. Now, e to the negative lambda 1 times e to the negative lambda 2 is e to the negative lambda 1 plus lambda 2. So that mess canceled out in the bottom. Okay. Let me erase a lot on the top and continue. So now it's mostly all algebra, if not 100% all algebra. Now, n factorial divided by k factorial divided by n minus k factorial is just n choose k. So I used that, so let's get out of it. Okay, so what's left on top is lambda 1 to the k times lambda 2 to the n minus k, that's over here, divided by lambda 1 plus lambda 2, all to the nth power. But n, lambda 1 plus lambda 2, n is the same as k plus n minus k, which is the same as lambda 1 plus lambda 2 to the k times lambda 1 plus lambda 2 to the n minus k. So the top is n choose k times lambda 1 to the k, lambda 2 to the n minus k, all divided by lambda 1 plus lambda 2 to the k times lambda 1 plus lambda 2 to the n minus k. erase some more, and we'll kind of be done. Just remember, when you divide two quantities that are raised to the same power, you can do the division first and then divide. No, and then raise to the power. You have a to the q divided by b to the q. You can do a divided by b first and raise that to the q. Oh, that didn't come out. I'm sorry. Okay. What I said was, if you have a to the q and you divide it by b to the q, notice the powers are the same. You can divide a and b first and then raise it to the q power. And that's the only thing we're going to do, and then we'll be done, and that will be it. So we have this piece, n choose k. Now everything is being multiplied or divided times this. N choose k times that. But the powers are the same. I can divide the bases, lambda over lambda 1 plus lambda 2, keep the power, and I can do the same with the next piece. It's lambda 2 over lambda 1 plus lambda 2, all to the n minus k power. And we know that this last line is equal to the probability that x is equal to k, given that, I ran out of space, but given that x plus y is equal to n. Okay, so this is just plug-in type of problem. If you are told, so if you are asked, what is the probability that x is 5, given that x plus y is equal to 11. Now keep in mind this is the same as the probability that x is 5, given that y is 6. Because if x is 5, what do you add to get 11? 6. So those two are equal. Now, this is what I'm calling k, and this is what I'm calling n. And suppose lambda 1 is 3, and, oops, that's not a lambda. And lambda 2 is 4. So what's the probability that x is 5, given that x plus y is 11? Well, just use this formula outright. It's n, 11, choose k, which is 5, times lambda 1, which is 3, over lambda 1 plus lambda 4 to the k. K is 5. Times, I'm just copying this down, times lambda 2, which is 4, over lambda 1 plus lambda 2, and we do n minus k. 11 minus 5 is 6. And you want to do a little arithmetic. 3 plus 4 is 7. 4 over 7 to the 6th power. And there will be the answer. So basically, this formula right here, you just plug in. You plug in the results, or you plug in the information, and the results come right out. Okay, that completes this section.